High-ranking military officials now admit 3I Atlas may not be what it seems, but something far more terrifying.
When the data from the Pan-STARRS and Atlas sky surveys converged in the late months of observation, astronomers noticed something so far beyond expectation that it forced a complete rethinking of what a celestial visitor could be. The object, cataloged as 3I Atlas, was first assumed to be another interstellar wanderer like 1I/Oumuamua or 2I/Borisov. Yet even in its earliest detection, there was something unnerving about the reading. Its light curve did not behave as expected, its apparent dimensions defied reason, and its gravitational interaction with nearby objects suggested a mass and size that stretched far beyond anything that had ever drifted through the solar system. What emerged from those weeks of observation was a revelation so staggering that astronomers began to compare it not to a comet or asteroid, but to an interstellar phenomenon of near-mythic proportion. Before we start, hit the like and subscribe buttons for more exclusive news. As telescopes around the world were redirected toward this new object, the first measurements confirmed that 3I Atlas was enormous, colossal beyond any existing category. The brightness, initially thought to be the result of a reflective surface or volatile material venting gas, persisted even after the object moved farther from the sun. This steady luminosity hinted at an intrinsic radiance or a surface area so massive that no simple model could contain it. When researchers calculated its probable size using the reflected light and its thermal emissions, the numbers escalated rapidly. The diameter estimates ballooned to several hundred kilometers, and later models, taking into account the strange thermal lag, proposed that 3I Atlas could span over 1,000 kilometers, possibly more. Such a size placed it beyond the largest known comets and even some of the dwarf planets. Unlike 1I/Oumuamua, which behaved like a shard of rock shaped by cosmic violence, and unlike 2I/Borisov, which resembled a standard comet exiled from another star, 3I Atlas was something else entirely. It was not merely a visitor, it was a juggernaut, a drifting worldlet from the deep of interstellar space. Its surface composition appeared uneven, patchy with regions that absorbed heat like metallic surfaces, and others that scattered light like crystalline ice. Spectrographic analysis revealed an astonishing blend of compounds, ammonia hydrates, silicates, and strange carbon polymers not commonly seen in any solar system body. There were spectral hints of exotic isotopes that implied formation around a star with an entirely different chemical fingerprint than our own sun. As it approached the outer regions of the solar system, 3I Atlas began to alter the dynamics of its surroundings in measurable ways. The gravitational tug it exerted on smaller asteroids in the Kuiper Belt was unmistakable. Some of the most precise instruments, including those aboard the James Webb Space Telescope and the European Space Agency's Gaia Observatory, detected minute deviations in the orbits of distant objects as the interstellar giant swept through. The data confirmed what many had whispered. This was not just another interstellar comet. Its mass alone was sufficient to disturb the fabric of the solar system's outer boundaries. For the first time, astronomers were watching an alien world pass close enough to rewrite the delicate balance of our cosmic neighborhood. The sheer velocity of 3I Atlas made its presence even more dramatic. It was moving faster than any natural object of such scale should have been able to sustain, nearly 90 kilometers per second relative to the sun. At that speed, it cut through the darkness like a silent, unstoppable leviathan. And yet, unlike other interstellar bodies that seemed inert, 3I Atlas pulsed with irregular fluctuations in brightness. Every few hours, the light signature shifted in a rhythmic pattern that some speculated might result from its rotation. However, the interval was too consistent, too mechanical for many to ignore. The possibility that it was tumbling chaotically was ruled out early. Its light curve suggested deliberate regularity. Speculation surged through the astronomical community. Was 3I Atlas a natural fragment of a failed planet? A remnant from the cataclysmic birth of another solar system? Or was it something more enigmatic, a construct shaped by processes unknown to human physics? The question wasn't born of sensationalism, but necessity. The scale, the composition, and the stability of the object defied the ordinary boundaries of planetary science. If it was natural, it represented a class of object that should not exist under known conditions. If it was artificial, it was evidence of cosmic engineering on an incomprehensible scale. Further analysis revealed that 3I Atlas emitted faint magnetic fields inconsistent with any cometary nucleus. These readings, though weak, pulsed in alignment with its light fluctuations, suggesting that internal processes, perhaps electrical currents or magnetic fluxes, were active within. Some theorized that a metallic core could generate such behavior, but the stability of those signals over long observation windows hinted at an even more complex internal structure. There was speculation of superconductive materials or trapped plasma flows, relics of ancient stellar activity frozen within its depths. As 3I Atlas neared the heliopause, the region where the sun's influence wanes, new data poured in from deep space probes. The object appeared to possess a faint halo, a diffuse shell of gas or dust stretching thousands of kilometers outward. Yet, unlike cometary comas, this halo was not composed of typical sublimated ice. The particles detected were heavy, microcrystalline grains embedded with rare elements such as osmium, iridium, and technetium. Their presence suggested violent origins, perhaps the residue of a destroyed planetary crust from a long-dead solar system. The notion that 3I Atlas might be a drifting fragment of a shattered exoplanet gained momentum. The implications of such a discovery were staggering. If interstellar space was littered with fragments of worlds, then 3I Atlas might be the first tangible evidence of cosmic recycling on a grand scale, a shard of creation itself, cast adrift by forces that shape galaxies. Its immense size could make it the remnant core of a planet ejected during the early chaos of its home system's formation. Or, even more hauntingly, it could be the exposed mantle of a destroyed super-Earth, its crust vaporized in a stellar cataclysm, leaving behind a naked, tumbling heart of matter forged under unimaginable pressure. What made 3I Atlas uniquely fascinating was its apparent stability across such extremes. Most interstellar objects endure millennia of bombardment and radiation, shedding mass and energy until they fade into obscurity. But this behemoth seemed almost impervious. Despite bathing in solar wind and cosmic rays, it retained its structure. Theories arose that it might be wrapped in an insulating layer of exotic carbon compounds, forming a shell that shielded its interior from erosion. The possibility of such natural armor raised new questions about how material might evolve in the vacuum between stars, where time and radiation sculpt matter into forms unthinkable on Earth. When astronomers simulated its trajectory backward through time, the results astonished them. 3I Atlas had not originated from any nearby star system. It had traveled for eons through interstellar space, its journey stretching across millions of years. Its velocity and vector placed its origin in a region between the constellations Lyra and Cygnus, near the galactic plane, where star formation is dense and chaotic. That region is home to massive stellar nurseries, and some speculated that 3I Atlas might have been expelled from the gravitational chaos of a multi-star system. If so, its passage through the void represented a story that began before human civilization existed, possibly before the Earth itself had cooled. Even more intriguing were the signals observed as it passed near the heliospheric boundary. Instruments detected low-frequency radio emission, faint and diffuse, yet synchronized with the object's rotational period. Such emissions could have been the natural consequence of charged particles interacting with the solar wind. Yet the regularity and spectral purity of the signals left room for mystery. In scientific journals, discussions became increasingly bold. Could an object of this magnitude, shaped by forces unknown, possess internal resonances capable of generating electromagnetic harmonics? Or could it be carrying within its structure remnants of magnetized plasma flows frozen in time, whispering through the vacuum in a slow, unending rhythm? To the human imagination, 3I Atlas was the embodiment of cosmic grandeur. For astronomers, it was a lesson in humility, a demonstration that the universe still guards secrets too vast for current science to decode. The more data was collected, the less it fit into known models. Its surface albedo fluctuated in ways that suggested layers of different reflectivity, possibly caused by buried deposits of glassy material or metals polished by micrometeoroid impacts. Thermal mapping revealed enormous contrast between its day and night sides, implying not only rotation, but perhaps internal heat retention. If heat was indeed being generated within, that alone would suggest a complex internal composition. Maybe radioactive decay, maybe residual energy from ancient compression. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on 3I Atlas being colossal beyond comprehension? We want to hear from you. Thank you for watching and see you next time.